Great. Good morning, students. Whether my screen is visible, I mean audible.
Yes, sir.
So, good morning, students. So, welcome to module 27 in the IC engine subject. Uh, in the diesel engine unit, right? So, almost we have seen what are the CI engines and working principles and the combustion stages and the combustion chamber design that we already we have seen these terms, right? So in this class we are going to see about the superchargers, right? So what is superchargers and what is turbochargers, right? So that we can see, right? So in our syllabus they given only the introduction about the superchargers, right? So first we have to know what is supercharger, right? Why we have to use the supercharger, what is supercharging, right? So that we are going to see, right? So the power and the efficiency of an ICE engine are increased with increasing the compression ratio, speed of the engine, and the charges density, the working substance, right? Working substance density, and it will reducing the exhaust temperature, right? Exhaust gas temperature, right? So our ultimate aim is to increase the power and the efficiency, right? Our ultimate aim is to increase the power and the efficiency, right? So for that, what we can do, that we can see, right? So we have to increase the power and the efficiency of an IC engine with the increase, right? With increasing the compression ratio, the speed of the engine, and the density of the charge, right? And one more thing, we have to reduce the exhaust gas temperature, right? So by controlling these, we can improve the performance of an engine, right? So by increasing the compression ratio, by speed of the engine, by increasing the mass flow rate, that is the density of the charge, right? So we introduce some modification in the engine, right? That modification is called the supercharging, right? The modification is called supercharging, right? So by using the supercharging, we can improve our engine performance and the efficiency. So what is supercharging, right? So the supercharging is a device, right? A compressor like device, right? It is a compressor like device. It will increases the air, right? It will increases the inlet air pressure as well as the mass flow rate, right? It will increases the inlet pressure air and the flow rate, that is the density, right? So it will increases the charge, that is the airflow, right? Airflow will be increases. So in order to increase the airflow, then automatically we can get the more power output and the efficiency, right? More power output and the efficiency, right? So that terming is called supercharging, right? That terming is called supercharging, right? So you have to remember, so what is supercharging? It's an important 2 mark question, right? So if the supercharging means we have to supply the more amount of the air, right? More amount of the air to the engine, right? So the more amount of air means obviously what is density? Density is a mass by volume, right? So what about the mass, right? Will be flowing in a particular volume, right? So if the volume, sorry, if the mass will be increases, automatically the density it increases, right? So we have to increase the mass flow rate of the air, right? We have to increase the mass flow rate of the air, right? So automatically what will happen, the density of the charges will be increases and the power output and the efficiency will get improved, right, in a engine, right? So that the supercharging, that term is called supercharging, right? So this method is called supercharging. Then we have to supply the high mass flow rate into an engine, right? So we are using a device, right? We are using a device. That device is called the supercharger, right? So that device is called a supercharger, right? So it's like a compressor. It's like an air compressor, right? It's like an air compressor which compresses the air, right? Which compresses the air to the high pressure, right? So if the pressure will be increases, right? So it will increases the pressure as well as the mass flow rate, that is the density of the air, right? The density of the air supplied to the engine system, right? It supplies to the engine system, right? So that device is called a supercharger. It is the air compressor, right? It is the air compressor which is used to increase the pressure and the flow rate of air, that is the density of the air which is supplied to the engine system, right? So that device is called the supercharger, right? So once the air supply is more, right, once the mass density will be more, so what will happen means the oxygen content, right, the air will be containing the oxygen, right? So that due to that oxygen, so what will happen, the combustion will be somewhat better, right? The combustion will be somewhat better. So the engine efficiency is obviously improves, right? The engine efficiency is obviously improves, right? So why? Because we have to get a more air inside the cylinder, inside the combustion chamber, right? So the more air means it will contains the more oxygen, right? It will contains the greater mass of the oxygen per cycle. So the combustion will be somewhat good, right? So the combustion will be somewhat good. So what will happen, its efficiency is automatically improves, right? Why? Because greater oxygen per cycle will gives the better combustion, right? It will gives the better combustion, right? So automatically the power output of the engine will be increases, right? So this term you have to remember, right? So what is supercharging and what is supercharger, right? Then we have some objectives, right? We have some objectives, right? Same what we discussed in the last slide, the same is the objective, right? So we have to obtain more power, right? We have to obtain more power from the existing engine, right? From the existing engine, right? So that is major objective of the supercharging, right? Then we have to increase the power output, right? We have to increase the power output and the efficiency by reducing the weight and the bulk of the engine, the weight and the bulk of the engine, right? So in most of aircraft, say the engine weight will be reducing, right? The and the racing cars, the engine weight will be reducing, right? So how we can reduce the engine, right? Once the engine weight will be reduces, so the power will be reduces, right? So we overcome that one, so we have to use the superchargers. We have to use some superchargers, right? So in game itself you can see most of the game in car game, most of we are playing the car game in the computers or a mobile, right? So while going in a normal mode, right, it's a different one, and we are using some gases, right? So இதெல்லாம் பாத்திருக்கீங்களா? அது கேம்ல விளையாடி இருக்கீங்களா அது மாதிரி? So extra power நம்ம ஏதாச்சும் நைட்ரஸ் கேஸ் கொடுத்துருப்போம், so the engine will be runs at faster manner, so it will get more power, right? So have you feel that one? அதை நீங்க எல்லாம் ஃபீல் பண்ணி விளையாடி இருக்கீங்களா அந்த மாதிரி?
Yes,
Yes,
sir.
right. So what will happen, so if we are giving some external source, we are giving some external supply to the engine, right? So the engine will get good performance or higher speed, right? So the same, right? So so here we can get the same power with the same engine weight, but we have to add some extra mass flow rate of the some gases, right? So here in the supercharging only we are using the normal atmospheric air, right? But in some cases what will happen, we have to use some external gases, right? So the nitrous will be used for to increase the power output, right? So we have to reduce the engine weight, we have to reduce the engine weight for the aircraft and the racing cars, right? So obviously it will generate the more speed of an engine, right? Then we have to reduce the weight as well as the size, right? We have to reduce the size of the engine, right? It will be fit in a limited space for the marine applications, right? So due to this reduction of the size of the engine, but we have to we are not compromising the power output, right? So the supercharger will be used to obtain the greater power in a small size engines also, right? So the supercharger here also we have some objectives on the superchargers, right? Then we have to overcome the effect of the high altitude, right? We have to overcome the effect of the high altitude, that is the power losses, right? The power losses that we have to reduce in the aircraft engines, right? We have to reduce in aircraft applications. Sorry, we have to reduce in aircraft applications, and most of the installation on the mountains, right? So the engine will be used for using in the mountain areas, right? So there we can use the superchargers. There we can use the superchargers to overcome by the power loss which is occurring in the high altitudes, right? To compensate, so the superchargers will be compensate the power losses, right? It will compensate the power losses which is used in a higher altitude, right? So these are the objectives, right? These are the objectives will be used there in the supercharging method, so supercharging method, right? Is it clear? Right. So I already told that the supercharger is a device. It's a compressor like device. It is a compressor like device. So what will happen? The compressor will compress the air, right? So it will compress the air means automatically pressure will be increases, right? So pressure will be increases. So we have to supply the, see here it is the engine, right? So it is the engine, right? So we have to supply the air and we have some exhaust, right? So inlet and the exhaust, right? So for the inlet we have to supply the air, right? We have to supply the air, right? Working substance, right? So in this air we have to supply the more pressure or more amount of air will be passing through this inlet valve. So what will happen? It will contains the greater amount of the oxygen. It is very easier to give a better combustion, right? So if the combustion will be better, so automatically the engine performance will be good, right? So we have to supply the greater amount of the air, right? So it will contains the greater amount of the oxygen. So how we can supply the greater amount means, so we have to get the air from the atmosphere, right? We have to get the air from the atmosphere and it will be compressed, right? So once it will be compressed, what will happen? It will create the high pressure, right? So once the high pressure gas will be gets into the cylinder, so the amount of flow, the amount of mass flow rate will be increases. So what will happen? So automatically we can say the density will be increases, right? So in the engine you can see the volume will not be changed, right? In the engine the volume, it's a constant one, so the volume will not be changed. So generally what will happen? So the density is the mass by volume, right? So here the volume will be the constant, right? So if the mass flow rate will be increases, so what will happen? The density is automatically increases, right? The density is automatically increases. So it will helps to give the better combustion. It will helps to give the better combustion, right? So you can see here, so the combustion chamber is a device, right? It is a device. Why we have to use this device? We have to supply the more amount of the air, so the more pressure air will be supplied, so that it will increases the pressure of the air in the intake, right? So that is in the intake manifold we have to supply, in the intake manifold we have to supply the more pressure, right? So which is above the atmospheric pressure, right? So what will happen? The supercharger, it will give the more pressure means, so automatically what will happen? The mass flow rate by the compressor is very high, so the mass flow rate of air will be high, right? Is it clear or not, right? So if the mass flow rate will be high, so what will happen? It automatically increases the density, right? It will automatically increases the density. So once the density will be increases, so what will happen? The oxygen which is present in the air will be more, right? So the more oxygen will gives the better combustion, right? Which gives the better combustion, right? So what will happen? So automatically the performance will be, the power output will be increases, right? So that device is called the supercharger. Then how the supercharger will be runs, right? How the compressor will be runs, right? So it may be run by a manual one, or it may be a geared, or it may be a belt drive, right? So whatever may be, right? So the supercharger it can be driven by mechanically by belt, chain drive, or the gear, right? So the power output from the engine, the power output from the engine, right? So you can see, so once the engine will be runs, right? So once the engine will be runs, so here some output power will be there, right? And here we can utilize some our power output. It is to run the external sources. It runs some external devices, that is the compressors, AC, right? So the here the load, right? So here the efficiency, the thermal efficiency will be calculated by here, right? So we can utilize some energy with, like, we can utilize some power to run these drives, right? So these drives will be driven by the engine, right? So these drive will be driven by the engine. See, so here the supercharger is driven by any mode, right? So either it is a belt conveyor or the chain drive or a gear, right? So it will get power from the engine's crankshaft, right? It will get the power from the engine crankshaft, or in some cases the compressor will be run by the external source also, right? It will be run by the external source also, right? So it is the general format of the superchargers. It is the general format of the superchargers, right? So uh, one okay, right? Then we can see, so the you will be clear in this slide, right? So how the superchargers will be works, is it clear? Anyone?
Yes, sir.
Okay, right, fine. So the supercharging power, right? So the power required to drive the supercharger, right? So we have to run the compressor, right? So where the power can be gets means from the engine, we have to utilize some power and we have to run the compressor, right? So what is the power required, right? So what is the power required by the compressor, right? So that we have to calculate, right? So we can say the general steady flow energy equation, right? The steady flow energy equation. So here the internal energy is there, then the enthalpy is there, and here the work, right? So we have to give some work to the compressor, that is a supercharger, right? So we have to give some work to the supercharger, then we can get the high pressure. So in this diagram you can see, so here the air inlet to the compressor from the atmosphere, right? So here the term will be 1, right? So once the compressor compresses the air, so here the output it will be the 2, right? So we have to give some work to the compressor, right? From the engine we have to give some work, right? So we have to give some work to the compressor, right? So then only what will happen, so the term which is from the inlet is 1 and to the outlet is 2, right? So the same I will draw here, right? So here the second one, right? So here uh, the terms will be 2. So here the pressure will be increases, velocity increases, temperature increases, energy increases, right? So why? Because we have to give some work, right? So right, then we have to increases the power, and we have some heat also, right? So in the supercharger there is no heat loss, right? So the heat loss will be neglected here, there is no heat loss. So what will happen, so the work done, right? So the work, what are the work we have to give to the compressor means, so the energy output minus the energy input, right? So the energy output and minus the energy input, right? So generally what is, so U plus PV, so internal energy plus the pressure and volume, it is called the enthalpy, right? It is called the enthalpy, right? So the enthalpy term will be represented at the H, right? So here the enthalpy output and the enthalpy input, right? So the difference between the enthalpy output is called the work done, right? It is called the work which is required, right? The work will be which is required, right? So here you can see, right? So it will be denoted as the specific heat and the temperature difference also, right? It will be represented as the specific heat and the temperature itself, right? So generally the power required by the compressor is the mass flow rate and the specific heat and the temperature difference, right? So you can see, right? So this is the heat supplied or heat rejected terms, right? So the M, that is mass flow rate, Cp, and the temperature difference divided by the enthalpy, right? So generally we can define the power, right? So what is the power? So what is the work done and what is the heat will be supplied or heat will be rejected, right? So Q by W, right? It is a power, right? So instead of Q, right? So I written here, right? So M Cp dt and divided by the enthalpy of the term divided by the work done, right? So here I can denote it as the work done, right? So the power required by the compressor to run the supercharger, right? The power required will be used for to run the supercharger is by calculated by this term, right? Then the types of the supercharger, right? So the types of the supercharger, right? So we have to compress the air, right? We have to compress the air, right? So that is our ultimate aim, that is the supercharging, right? So here we have two types of the compressors, so one is the positive displacement type and second one is the dynamic compressors, right? So one is the positive displacement type and the second one is the dynamic compressors, right? So in this positive displacement type, right? So in this positive displacement type, which is delivered nearly a fixed volume of the air, right? So it will be deliver the fixed volume of air per revolution at all the speed conditions, right? So at all the speed conditions it will give the constant volume of, that is the fixed volume of the supply. So the level will be the constant, right? So the level will be the constant in all speed variation condition. It will be called as the positive displacement. It will be called as the positive displacement, right? Then the second one is the dynamic compressor. Second one is the dynamic compressor, right? So if the dynamic compressor, if the accelerating is high due to the high speed of the rotating part, high speed of the rotating part, so then the velocity and the pressure, it will be increases or it will be decreases by the rotating element, right? So that I can explain in the slides, right? So first we can see the positive displacement, right? So here you can see the animation, right? So here we have a supercharger, right? So just I can explain one by one. Mm, right. So the first term, you can see what is the first term? It is the compressor. Sorry, it is the air filter, right? So in a car, you almost see. So you have the air filter, right? So it will filters the dust from the atmospheric air. So it will be filters, right? So the filtered air will be gone through the manifold, right? So it will be the pipeline, right? The second one is the pipeline, right? So the air will be goes through. So here you can see the fourth part, right? Here you can see the fourth part. So it will be runs, you can see, right? So it will be runs, right? So have you seen that one, the fourth and sixth one, you can see அது ரொட்டேட் ஆக தெரியுதா உங்களுக்கு, anyone?
Yes, sir.
Right. So what will happen means, so the air, right? So the air from the one and two. So what will happen? The air will be sucked from the through the filter and the inlet manifold. So the pressure will be atmospheric one. Pressure will be the atmospheric one, right? So once it will be enters into the fourth one, this is called the pump, or it is called the compressor. It is called the compressor. So here what will happen? The air will be compresses. The air will be compresses and it will be supplies to the engine. Right? So how the engine, how the compressor will be runs means, so it will get the power from the belt drive. You can see the eighth one. You can see the eighth one. So for the eighth one, where it will gets the power, right? So for the belt drive, you can see the 8 and 9, right? So 8 is the pulley one, right? So 8 is the pulley one, and 9 is the belt drive, which is run by the crankshaft, right? Which is run by the crankshaft. So you here you can see it is the crankshaft, right? It is the crankshaft which is gets the power from the engine, right? Engine output, right? So in this crankshaft, what will happen? We have some belt drive, and we can run the this part, right? We can run this part will be connected through the compressor, right? So the compressor will be run by the engine output by using the belt drive, right? So here you can see, is it clear or not? Then here we have the seventh point, we have some seventh part here, right? So that I can explain, right? So just you can see how the superchargers will be works. Is it clear? Is it clear or not? Anyone?
Yes,
Yes,
sir.
sir.
Yes, right. Then how we can increase the power, right? So here you can see, here you are see, no, see this rotating part. So here you can see it is the rotating part, right? So in this rotating part, what will happen? The shaded part, you can see here. Here the parts will be rotates, right? So that will be I shown here, right? So once the inlet from this side, right? So once the inlet gas, the inlet air will be, the atmospheric air will be comes through this side. So what will happen? So the inlet will be comes through this side. So here the pressure will be low. So it will be rotates, right? It will be rotate. This type of the pump, this type of the compressor is called the screw type compressor, right? So here you can see the setup, right? So here we have two screws, right? Two screws. So what will happen? It will be rotate. So while rotating, what will happen? The air mass flow rate, right? The air will be passing through this this term, right? So the between the two threads, between the two threads, the air will be passing through. So what will happen? The air will be compresses, and we can get the high pressure gas in the outlet. We can get the high pressure gas in the high pressure air in the outlet. Whether it is clear? Clear earlier by
Yes,
then?
sir.
Okay, right. So this one type of the compressor, this one type of the compressor, this type is called a screw type one or a root one, right? Then here it is a vane compressor. It is called the vane compressor, right? So here you can see the number of elements, right? So here you can see here the needle structure, right? So these are called as the vane. These are the called as the vane. So what will happen means, so the vane will be adjustable one. The vane will be the adjustable one. So once what will happen, the air will be sucked from the atmospheric air, then it will be passing through the small area, right? So small area. So what will happen? So here you can see, so the area will be goes on in a reducing manner, right? So in a reducing management, what will happen? So its pressure will be increases, right? It pressure will be increases, and it will discharge the high amount, the high pressure, right? It will discharge the high pressure air to the outlet one, right? So this type of compressor is called the van type compressor, right? So this type of compressor is called the van type compressor. And here we have, you can see here the two lobes, right? So this one lobe, right? It is first, it is one lobe, and here it is the one type of lobe, right? So here we can rotate the two types of lobe, right? So the air will be passing through between these two lobes, so automatically the pressure will be increases, and it will be delivered to the engine, right? So this also called as a twin screw, right? It is called the twin screw, the compressor. So here we can call it as a compressor or a supercharger, right? So supercharger is a compressor like a device, right? So here I can explain as the compressor or a supercharger, right? So once it will be rotates, what will happen? So here we have an outer casing, right? So the air will be passing in the outer casing, so it will increases the pressure, it will pushes and it will increases the pressure, right? So this also is same, right? You can see the rotating element, right? So here if we have some gap, right? So in this gap, what will happen? The pressure will be increases, right? So here it is a dynamic one. So we have seen this and all a positive manner. Why? Because the fixed amount of the volume will be supplies. But here you can see it is the rotating dynamic one, right? So if the pressure will be higher, right? So pressure will be higher, it will be runs at a faster manner, so it will get the high pressure, right? So here the volume will not be constant one, right? So here we can get the high pressure, right? So what will happen? The charges will be comes into the rotor. So here you can see like a pump, centrifugal pump. Have you studied it in a fluid mechanics? Fluid mechanics centrifugal pump படிச்சிருக்கீங்களாப்பா? Centrifugal pump. So what is the function of the centrifugal pump? It will increases the pressure, right? It will increases the pressure of the flow. Is it right or not? Right? It will increases the pressure of the flow, right? Then we have different type of the methods. We have the different type of the methods of the supercharging. We have to different type of methods for the supercharging. Okay, right. So our ultimate aim is to increase the mass flow rate, and we have to increase the pressure, right? So that one type, but here we have some disadvantage. Here we have some disadvantage, right? What is that means? So if the engine will get the temperature of the air, if it will be increases means it will reduces the efficiency. It will reduces the efficiency, right? So here we have to supply the air temperature will be somewhat reduced manner, right? We have to reduce air supply, we have to give, right? So if the engine inlet air temperature increases, so what will happen? It will reduces the efficiency of the engine. It will reduces the efficiency of the engine, right? So obviously if you are using the air which is compressed by the supercharger or a compressor, so what will happen? The high pressure gas will be supplied to the engine, right? So if the high pressure will be generated by the supercharger, so what about the temperature? So it is automatically increases its temperature also. So the inlet air temperature will be increases, right? So the higher temperature to the inlet air is not good, right? So it will reduces the engine performance and it will reduces the efficiency. So we are introducing here one cooler, right? So we have to cool the air, right? We have to cool the air, but at the same time we are not compromising the pressure. We are not compromising the pressure, right? So if the pressure will be reduces, what will happen? The density also reduces, right? So it is not, it will not use, it will not improve our efficiency of the engine, right? So we have to supply the same pressure which is generated by the supercharger, right? So that same pressure we have to supply into the engine. At the same time we have to reduce the temperature of the compressed air. We have to reduce the temperature of the compressed air. So we have to use some coolers. We have to use some coolers, right? So that coolers will be cools the compressed air temperature. We have to cool the compressed air temperature, right? So uh, so the air cooler will be used between the air compressor outlet and the engine inlet. So we have to use the air cooler, right? We have to use the air cooler which cools, right? Which cools the temperature of the compressed air, right? So we have to use one cooler part, right? We have to use one cooler term in between the output from the compressor or a supercharger and the inlet to the engine, right? So there we can use a small air cooler, right? So why we have to use the air cooler? We have to reduce the compressed air temperature, right? So if the cooler will not be there, what will happen? The engine performance, the engine efficiency automatically reduces, right? So we have to supply the inlet air temperature will be increases, mean automatically it reduces the engine efficiency, right? So we can avoid that one, right? So the engine performance will be has to improve. For that only we are using the superchargers, right? So we have to supply air in a cool manner, right? We have to supply the air in a cool manner. So we are introducing the air cooler between the supercharger and the engine input, right? So here we have the plenty of methods to the arrangement of the supercharging terms, right? So the first one is the compressor, which is driven by the engine, right? Which is driven by the engine, right? So just you can see the methods. then we can explain these terms in the afternoon class, right? So now just you can see what are the methods are there in the arrangement of the supercharging. So the first one you can see, the first one. So the compressor will be, how the compressor will be runs, right? So it will be run by the engine output, right? It is run by the engine output. So the compressor will be driven by the engine. It is the first one, right? It is the first arrangement of the supercharging, right? It is the first method to arrangement of the supercharging. And the second one, right? So here you can see the how the compressor will be runs, right? How the compressor will be runs, right? So here you can see the compressor, right? So the compressor will be driven by the turbine. It will be driven by the turbine, right? So the compressor will be driven by the turbine. It is a second method, right? It is a second method. And the compressor will be run by either the external source, right? So from the external source the compressor will be runs, right? So this one type of the method. And the compressor will be driven by the engine shaft. The compressor will be driven by the engine shaft. And here we are using the turbine also. We are using the turbine also. So the turbine will be somewhat free, right? So the turbine will be somewhat free, right? So the supercharger will be works. The compressor will be works by the engine output, right? So this one type of method. And here the last method, right? So the turbine and the compressor, right? So will be coupled through the engine output. So the direct coupling, so the direct coupling between the engine, turbine, and the compressor, right? So these are the methods will be available in the supercharging methods, right? So these methods we can see in the afternoon class, right? We can see in the afternoon class. Then we have one more term, right? So that is called the supercharger. That is called the turbochargers, right? So we have superchargers and we have the turbochargers, right? So these term we can discuss in the afternoon class, right? So is it clear? So what are the terms will be discussed in this class? Is it clear or not?
Yes, sir.
Okay. So do you have any doubt? Means just you can ask. Otherwise you can leave the class.